So today we are going to see how actually insertion sort works and what is the intuition behind it. Okay, so let's take an array which is let's suppose you taken an descending order array and you have to sort it in the uh, increasing order. Okay, so let me first tell you the basic idea of insertion sort is, like for example you have an sorted array, like you can take any sorted array like 1 2 3 4, and what you have to do is you have to put I think I would add one more element to like 8 and 9. Okay, so this is the array that you have taken which is in the sorted fashion. Okay, so if I say you that you have to insert 6 in this particular array, so how would you insert in that? You will find where 6 will go. So either you can start from this side, that where I can place 6, this is less than 6, so no. Move forward, this is less than 6, no. This is less than 6, no. This is less than 6, no. This is greater than 6 and this is smaller than 6. So in between this you have to insert 6. Again, if I say you that you have to insert 7 into this sorted array, how would you insert? Maybe let's suppose if you take this time from this side, so you will see that 9 is greater than 7, no. Move forward, move backward. 7 is greater than 8, then move next. 6 is less than 7. So the point where you find the next element is greater and the previous element is smaller, at that point you will put the seventh element. So you will create an space and put it 7. Actually you have to shift this particular element to this side, and 9 will go to this side, and this will become 8, and this will become actually 7. So this is the main idea behind insertion sort. You have to put the elements in sorted fashion, which means in the right it should be greater than 7, and in the left it would be greater than less than 6. Now let's see how we can sort a particular array. So let's suppose we have taken any particular array. For example, we have taken like any 4 6, or it is, I think it is sorted order, so 9 6, then you can say 7, then 3, then 1, then I think 2. So now let's start doing the iteration. So what we have to do initially, you will be taking the array, and what you need to do is first you will stand at this position, and you will say that before this particular element everything is sorted. Before this particular element everything is sorted. So 9 6 7 3 2 and 1. Now we are saying that before like till this particular element everything is sorted. As you can see, if I hide you and show it up to you, is 9 in the sorted fashion? Yes, because it is a single element. Now move this pointer to the next element. So let's move the pointer. So now you move the pointer to this particular element. Okay, so 9 6 7 3 2 and then 1. Now we are saying that until this particular array everything is sorted, but you actually found that this particular element has smaller value and it is in the right. So what you will do is that you assume that this up to this is sorted, but actually this is not in the sorted order. So what you start doing is you take 6 and move to the left side and check until which the element is smaller than 6. So you find that 9 is bigger than 6, so move forward. So after 9 there is no element. So what we do is we just take this element and put it before this particular element. As we will move forward, this will be more clear to you. As we will move forward, you will exactly going to know how actually it is working, because since there is only 2 elements, that's why there is having problem. So we have assumed that until this second element everything is sorted, but 6 was not sorted, so we take 6 and move it in the left direction. So if we did this, then it becomes sorted. So and keep it rest of the element as it is, because until this we are only assuming that everything is sorted. So keep other at as it is. Okay. Now in this particular iteration you will get to know why how exactly it works. So now we are assuming till 7 it is sorted, but check, it is actually sorted. No, 7 has to be in the right place. So how can we place 7 at the right place? So first just make a cell to place it on, so keeping rest of the thing as it is. So there is 6, 9 and 7. Okay, now what we need to do is 7 is there, so what I have told you, just take this element 7 and start moving in the left direction. So take 7 and move to left. Is it greater than 7? Yes. Then you don't have to do anything, just move to the left. In the left you found that someone is less than 6. Oh wow, that you have found this position, because what we are assuming, until this particular element everything is sorted. So if this whole array is sorted, so and if we are trying to put 7 into it, and you seen that in this index the 6 is smaller than 7, and at this index 9 is greater than 7. So what you have found, in between these two element you have to put 7 into it. So just take this element and just you have to take this element, and this place will be empty, 7 will be removed and it will be empty. Now start shifting 9 to its right, 9 to its right. So first we have popped out 7, so it is 7, you can place it somewhere. Now shift it to the right, so 9 goes here. And now since we only have to since we found at the first position, so we only need to shift one position left. So now put 7 in that position, so instead of 9 it becomes 7. As we move forward things will be more clear to you. Okay, so 7 is placed at the correct position, right? So instead of this you will say that it is 9 and here it is 7. Okay, now let's since this position we have sorted up everything, as you can also see till index 2 we have sorted everything, 6, 7, 9. Now let's assume that till this particular element we need to sort. So what you are saying that till here everything is sorted and 3 is not sorted, so we have to put it in its correct position. So what we will do is we just remove out the 3 from it, so just remove out and save somewhere. And what we have to do, just shift element until you found someone less than 3. So 9 shifted at this particular element because 9 is greater than 3. So 9 is removed and it is shifted towards right. Now check next one, is 7 less than 3? No, it is greater. So again move it to the right, 7 goes here, this will be cut. Again move to the left and check, is 6 less than 3? No. So move 6 also to the right, and after this the array becomes, because you cannot go after this, so put the 3 over this particular index, so 3 goes to this index. So the final array becomes 3, 6, 7, 9, 2, 1, 1. Okay, now as we have assumed till this particular index, that is 0, 1, 2, 3, 4, 5. So now move this pointer to the next. Now we are assuming till this particular index we need to sort it up. So this is the sorted and only 2 is not sorted, so just remove out 2 from here. So we remove 2 from this array, so it becomes empty. Now start shifting the element toward right until you found someone until you found someone less than 2. So 9 is greater than 2, so shift it to the right. Now again check 7 is greater than 2, then move it to the right, 7. Again check 6 is greater than 2, so move it to the right. Again check, is 3 greater than 2? Yes, so move it to the right. And since after this you cannot check, it is empty, so put this 2 over this particular index. So the final array becomes 2, 3, 6, 7, 9 and then 1. So let's suppose if we take 4, then I think the concept will be more clear, since 1 is still at the same position. So I think taking 4 will provide you more clarity how it works. So let's suppose let's take it 4. So the what we have assumed till now, that until this particular index it is sorted. So now now check for the last element. Okay, so 4. Now you just remove from 4 from this particular index and keep it aside. And now check that until now shift element until you found someone less than 4. So 9 is greater than 4, so just move it to the right. So 9 comes at this particular index. Again check, is 7 less than 4? No, then you need to move it to the right. So 7 also move to the right. Now check, is 6 less than 4? No, then move 6 also to the right. Now check 3. Yeah, you have found that someone is less than 4. So as you have found someone is less than 4, you have found its correct position. So this is the correct position for 4. Now put 4 over there. So until you found someone less than that particular element, then until then you have to move all the element to the right of it. So now the final array becomes 2, 3, 4, 6, 7 and 9. And after this, if this pointer goes out, so it goes out from the array, so the iteration ends over there, and you can see that you have got the whole array to be sorted. So summary, what we have did till now is, first we assume that until first index it is sorted. We just hide everything and assume that this is sorted. Okay, then move the pointer to the next element and checked, is this sorted? No. So where we can put 6 so that it becomes sorted. So 6 need to placed before 9. So 6 move to the left, so it becomes here it will be 6 and here will be 9. So after this particular thing, we move pointer to the third and checked, is 7 in the correct position? No, 7 was not there, so we shifted the element which were greater than 7. So only 9 was greater, so only 9 shifted to the right, and check that 6 was less than 7. So we kept 7 and moved the pointer to the next, and accordingly we have sorted the every element and moved the pointer accordingly, and finally we got the sorted array. The main thing is what we were doing here is, we are taking one pointer that was moving to the index 0, 1, 2, 3. It was moving, right? So first we need to this particular array. So I would go from 0 to n minus 1. Okay, now inside it, what we were doing, we were checking that wherever is the pointer, is this particular element, wherever the pointer was, is this particular element is in the sorted form, or we need to insert this element in this particular sorted array. So let's take another variable j, which will start from the same pointer, and what we have did is, we were moving to the left direction, because remember, when the pointer was here, we were picking this element. So instead, for understanding, I have said you that you will pick element. So in coding you will pick that index, because when you need to swap it, or when you need to move the element to the right, you need indexes, not the numbers. So you need to store the number. That's why wherever the pointer was, we have stored its index, and now we need to go to the left. So how we can go to the left? So we can check if the array of j minus 1 is greater than ARR of j. What does it means? That uh, the left element is greater than the right element, which means this was there. The left element was 7 and right element was 6. If I show you up in the original array, like for this particular example, 7 was bigger and 3 was smaller. So we were taking 3 and putting it into the correct position. So the first condition is this, that we need to check the j and the j minus 1. If the left element is greater, then only we need to go to the left. And what was the another condition? Until the 0th index, if we don't find, then don't need to go beyond this, because it will cause you an exception. So another condition we would write is only check until the j is greater than or equal to 0, because after greater than 0, because j minus 1 already checks the 0th index. So don't go to the 0th index, only go to 1. That's why it is written greater than 0. Now inside it, what I have told you, you have to go to the left. So how can you go to the left? Using j minus minus. But what we have to do with j minus minus? So let's write first. What we need to do is, you need to move the element to the right and then do the j minus minus. So first what we will do is, we will say that swap ARR of j and ARR of j minus 1, and then you need to just move to the left. So what exactly we are doing? We are just swapping, because if we will swap, then it will automatically move to the right, because we were taking out this element and just swapped it. So until you found someone less than that particular element, and then until you can do it up. So this is the whole code. And if you need more clarity, you can take more example, and you can check doing this how exactly it works, so it will be more clear to you. So this was the the explanation. So what is the time complexity? So for the inner loop, it is big O of n, and for the outer loop, it is big O of n. So the both will combine and give you a time complexity of big O of n square. And since we are not using any space, we are only using the array itself to sort the answer. So you can say the time complexity is big O of n, but we are not actually using it. We are just using to return the answer. So this is the time complexity and space complexity of this particular sorting algorithm.
So let's code it up and see how we can code it. So what we have told you, take a pointer which will go from I to 0 to less than n, actually n minus 1 times, and inside it take another variable that will be swapping, or that will be used to move the element to the right. So j is initialized as the ith position, which I have told you that j will move to the left. So what we need to check, j always should be greater than 0, and if ARR of j minus 1, if it is greater than ARR of j, which means the left element is greater than the right element, which is in the unsorted order, then what we need to do is, we just need to swap these two elements, right? So take a variable temp and assign it to ARR of j, and ARR of j would be ARR of j minus 1, then ARR of j minus 1 will be temp. So this is the swapping code. You can define it in separate function, or you can do it here. It is up to you. So this is for the swapping. And what is the main thing that we need to do is we need to go to the left direction. So j minus minus until you found someone that is less than j, or maybe you will reach to the reach to the end of the array, or you can say start of the array. So this particular code will sort your array. So let's check by printing it. So for int x in arr, now south and remove ln and x plus space. Now let's run in and check whether it is working fine or not. So as you can see here, it sorted up all the taken values which are given in this, and at last I have told you that change this to 4 only for the explanation, but I am showing also there that if you change 4, then again it will sort in the correct order. So 1 was there, so instead of 1, if we put at 4, so where it will insert at 6 and 3. So this is the final code. So thank you for watching this video. If you have found this explanation good or you have understood something, then please like, share and subscribe.